Central Michigan University, CMU in Mount Pleasant, Michigan, began a $22.5 million renovation of its Rose Event Center in 2009. The renovation included the addition of 20 rows of seating above an existing mezzanine concourse area. My company, Albanelli Cement Contractors, was selected to place the concrete treads for the new seating. The treads were designed as 2-inch lightweight concrete slabs placed on a 9/16 of an inch form deck. Although a relatively small volume of concrete was required for the entire placement, the potential placing problems were large. The concrete had to be placed on an upper floor of an enclosed arena, so pumping the concrete was the only efficient placing method. Unfortunately, there was only one access point to deliver concrete for all of the treads, and it was impossible to use the pump boom to move the discharge line to the treads. The solution was to use the boom to supply concrete to a 210-foot-long, 4-inch diameter steel pump line inside the arena. 20-foot-long sections of 3-inch diameter rubber discharge hose were connected to the pipeline so that workers could place concrete within the narrow treads with minimal effort and fatigue. Because minimizing dead load was a dominant consideration, we chose a lightweight concrete solution. Based on past experience with lightweight concrete, we were concerned about line blockages, especially because of the 3-inch diameter discharge hose. And because hand finishing was anticipated for the narrow treads, we were concerned that the lightweight concrete with entrained air might delaminate during hard troweling. I met Larry Chappell of Syntheon Incorporated, a wholly owned subsidiary of Nova Chemicals Incorporated, and manufacturers of Elemix Concrete Additive, a product consisting of lightweight synthetic particles, polymeric spheres specially formulated for use as a concrete additive. The spheres distribute uniformly throughout concrete, reducing the need to use air-entraining admixtures to achieve desired density reduction. We knew the latter feature could be critical for the CMU project, as entrained air can fluctuate during pumping or cause problems with finishing such as stickiness or delamination. The next step was getting the concrete supplier to use a product with which they had no experience. Central Concrete Products readily accepted the challenge, using laboratory trial batches to determine mixture proportions. The entire placement was completed in 3 working days, far less time than had been anticipated. The payoff was a high-quality surface produced on schedule with no pumping or finishing problems.